Now, in this last part, we're going to look at an interesting relationship between the angles and the sides that are opposite them. Now, this is an applet I created in GeoGebra, and you can see I started with an isosceles triangle. I'm using a circle to show the distances. I can set the length for the third side, and right now I have the two sides matching. So I have a length of 6 and 6 here. Now, if you look at this side, it's the green side, it's also 6, and everything matches. All three sides match all three angles. If I make the angle smaller, you can see that the blue and the red stay the same, but the green side is shrinking. So that means the smaller I make that green angle, the smaller the green side is. The bigger I make the green angle, the bigger the green side is. Now this will also be true even if I start changing sides. So you can see now that I don't have the same size for both. So this red 6, that's the smallest side. It's opposite the smallest angle. The biggest angle is 140, and the side opposite is the biggest side. The middle angle is 24 degrees, and the side opposite is this middle side. So what we saw was that what was true about the angles when the sides are all congruent. We found out the angles all have to equal 60 degrees. So when the sides were equal, the angles were equal. All right? And in fact, they were all 60 degrees. Now, when the vertex angle here, these two are congruent, when that vertex angle was smaller than 60 degrees, it was the smallest angle in the triangle, right? Then, what is true about the side opposite? Well, that's actually going to be the smallest side on the triangle. You can see the blue angle here is matching kind of with the 6 there. The red angle there is matching with the 6 there. And the green angle here is matching the green side. The smallest angle is going with the smallest side. Then we went ahead and opened it up where we have the angle being more than 60 degrees. So when this angle is the largest angle, what is true about the side opposite? Well, it's actually the largest side, which leads us to the relationship of sides opposite angles. The size of an angle is related to the size of the side opposite it. The longest side will always be opposite the largest angle, and the shortest side will be opposite the smallest angle. In this example, I'm going to classify triangle ABC using angles and sides, and then I'm going to list the sides in ascending order, even though I don't know the length of the sides. So first of all, I know the three angles have to add up to 180. So 3x plus 4x plus 5x is 180, which means 12x is 180. Divide both sides by 12 and I get x is 15. So the three angles are 45, 60, and 75. Well, that means that the angles are 45, 60, 75. So if I was looking at the sides here, the smallest side is going to be opposite the smallest angle. It's going to be side BC. Then the next smallest side would be opposite 4x, so it will be AC, and then finally AB. So these are the sides in ascending order: BC, AC, and AB. So this triangle is acute, and by the way, it's also scalene. If the angles don't match, the sides don't match. So for further reflection, how are opposite sides and angles in a triangle related? The biggest side is going to be opposite the biggest angle, and the smallest side will be opposite the smallest angle. And why must the sum of two sides of a triangle always be larger than the third side?